Hello, this is Antonello Romano speaking. This poster presents a case study that aims to analyze and compare original and synthetic geospatial data at the intra-urban scale. The goal is to explore the potential implication of the spread of synthetic data in AI-driven society and also in scenarios where geospatial data are essential for decoding socio-spatial changes and where geo-visualization is pivotal for spatial decision support. The methodology is based on A, the production of a synthetic dataset, and B, the evaluation of the spatial similarity with the original one. Specifically, we employ a synthetic data platform, namely Mostly.AI, alongside geospatial data related to Airbnb listing in Florence, Italy. Results show which criticalities are linked to AI-derived data compared to original ones, highlighting crucial spatial similarities and dissimilarities. This is because in today's data-driven and AI-oriented era, our decision-making processes rely heavily on data-driven insights. Scientific data, which is artificially generated using algorithms, play a crucial role in this landscape. In particular, we selected in this case an area in which data in general are not scarce, but on the contrary, an area in which data was found to be fundamental for making decisions and supporting territorial governance. Now, given that the level of similarity can vary depending on the method used in the dataset production, this study does not discuss which is the best method to produce synthetic data, but rather the critical issue that can emerge in terms of disinformation and misinformation that could derive from the growing diffusion of a large-scale synthetic data provider. So within this context, the research question concerns what is the degree of spatial similarity of the synthetic geographic data compared to the input data? What could be the consequences of large-scale production of synthetic geographic data? So to analyze the level of dissimilarity of synthetic geographic data compared to the original ones, data on the distribution of Airbnb listings in Florence and a synthetic data provider were used to produce the corresponding synthetic dataset. Specifically, a synthetic dataset of 12,000 Airbnb listings in the city of Florence was produced, identical in absolute number to the original one. Then the correlation matrix between the two datasets were then analyzed to assess the level of similarities with particular reference to the following categories: price per night, number of views, type of listings, number of listings per host, and location of the listings. So a spatial comparison between the two datasets was carried out using the hotspot analysis comparison methods. These methods measure how closely the hotspot, cold spot, and non-significant areas of both hotspot results spatially aligned. So this methodology allows for comparing the degree of similarity with particular reference to the spatial dimension, the distribution of listings on a microscale. Now, the two maps, as you can see, show pretty similar geographies, making it difficult to distinguish between the original dataset and the synthetic one, the A map and the B map. However, the spatial similarity index between the original map, the A map, and the synthetic dataset output cluster differently, including some areas within the historical center where the spatial similarity index is generally high. The spatial similarity index is very low outside the city center, confirming the challenges faced by synthetic generator in replicating the patterns observed in outlier values. Notably, some areas reverse their original properties, transitioning from hot spots to cold spots or becoming statistically insignificant. So, as demonstrated, simulated spatial data is distinct from generic data. While spatial data can be generalized across various contexts, explicit spatial data, such as data with latitude and longitude, is inherently tied to specific locations. However, synthetic data which approximate real-world data may not include all outliers present in the original dataset, even though these outliers are critical for certain contexts and applications. From this perspective, while the synthetic data may emulate the overall spatial data distribution from a geographical point of view, it falls short of emulating essential nuances present in the original data. In this context, the widespread availability of cloud-based synthetic platform raises significant concerns related to misinformation, disinformation, data quality, and accuracy.